Okay, so now I want to continue to talk about truth tables and in particular truth tables with implications, because this often causes some more confusion or bothers people a little bit, the definition. So let's look at the definition. So again, we're going to build a truth table to define what the implication is. So we need all possible truth values for P and Q, which are these, and then we can look at P implies Q. Okay, so the first one usually doesn't bother people. True implies true. That's true. Great. And the second one usually doesn't bother people. True implies false. That's false. That's bad, right? Okay, now before I fill in the rest of the table, I just want to say that let me just mention that the book, in the book, it is said that P implies Q is false if P implies Q is a lie. And I think that's the right way to think about this statement. So remember, implications are like conditional statements. If the first thing, then the second thing, right? So we want to ask, is it a lie, right? Is the implication a lie? And so that's, I think, helpful to think about when I fill in the rest of the table. Okay. So for the rest of the table, um, if you go false implies true, we say that that's actually true. Now that bothers people. And then false implies false is also true. But the way to think about it is if the starting statement is false, then the implication doesn't even get off the ground and doesn't even start. So it doesn't really matter whether Q is true or false. The fact that the first part of the implication is false means you don't even follow the rest of the implication because it's already, um, it means that the implication is meaningless. And so the implication hasn't lied to you in that case, is the way we think about it. The only time the implication has lied to us is when we have that P is true. And so we start this way, okay, the implication is, it works. And so we say, okay, and that means it implies that Q is true, but it doesn't. It implies Q is false. And so it's lied to us, right? So I think that's a good explanation of how to think about implication. But in my experience, this does tend to bother people. So, um, if it does bother you, then let me know, and I'd be happy to talk about this in my office with you. And you can also read the book's discussion of this a little bit more. So check it out. Let me know what you think. Um, so, again, just to play with this being a lie kind of thing a little bit more, you can think about something like the following, right? So let's say P is the statement that n equals 3 is even, and Q is the statement that n equals 3 is a natural number. Okay, so then I ask, does P imply Q? Is it true or is it false, right? Now, according to the table, it is true, right? But the way to think about this is that the implication doesn't even get off the ground because the P part is not true. And so I don't even follow the rest of the implication. And so the implication is true, even though it's not going to be useful to me, right? Because it doesn't lie to me. It doesn't, because P is false, I don't even follow the rest of the implication, so I don't get lied to. But we say that the implication itself is true. Okay, so this is true in this case. And it doesn't matter really what Q is. Okay, so again, think about this in terms of whether the implication lies to you or not, and if that bothers you, you can check out the examples on page 218. And feel free to discuss this with me if it still bothers you. But I don't want to spend too much time here because oftentimes I find when this bothers somebody, they need it's helpful just to specifically talk about exactly what is bothering you. Okay, so let's move on and work with the implication, because you can also just kind of like take this as a definition of what implication is, right? Of course, we also want to have intuition for it. So I don't want to discourage you from trying to build some intuition for implication, but you also want to just work with it in a careful way, and that just you don't need the intuition per se to work with it as a definition of this logical connective. Okay, so let's work with this a little bit and let's build the following truth table. So we're going to have P and Q. And I'm also going to define for you the next thing, which is P is equivalent to Q. So I'm just going to introduce it as if it's a definition, but then we'll see that it's equivalent to something involving the implication. So here, P if and only if Q, then it'll be true. In this case, it'll be false, false, and it'll actually be true in this case because the false goes in both directions. Okay, so now let's continue the truth table though, because we want to see its relationship to something else. So now let's see, what is P implies Q as a truth table? What is Q implies P, which is the converse? And the last one is P implies Q and Q implies P. Okay, good. So P implies Q, that's the one we just did. So that's true, false, true, true. This one is going to be true, true, false, true, right? Because again, it requires a true start to lead to a false conclusion. And so in this case, the Q implies P is false in the third row. And then when I and these two things, I just use the property of ands. The only way it's true is if they're both true. So this is true, false, false, true. Okay, so what that tells you is that this definition that I gave over here is equivalent to kind of what you expect, which is that P if and only if Q is if you have both implications. P implies Q and Q implies P, right? So, but also notice that because this row is the implication, and this row is the converse. So we already see that the implication is not equivalent to the converse. And we also see that P, if and only if Q, is equivalent to P implies Q and Q implies P. Okay, so that's important for later.